We're working Cal 1 problems, applications of differentiation, and we're looking at optimization. Alright, so we have a interesting problem here. Now, of course, in the previous video I said we weren't working any more rectangular problems. Well, any more general problems that have to do with rectangles. This is more of a specific case here. The farmer is fencing a rectangular pen for his hogs and needs to find the minimum perimeter with a given area of 10,000 square meters. Yeah, this is a really interesting problem here. There's a lot going on, a lot of hidden stuff going on. Let's see if you can figure it out. Okay, we have some unknowns, and of course, once again, we're going to have the length and the width are two unknowns, and we were given a number, and that was 10,000. This was the area, meters squared, however you want to say this. I think I said SQM, whatever, meters squared. All right. I guess we are going to draw a picture now, and hopefully you'll understand what we're doing here. I'm going to draw a picture. So this here is some waves, and this is water right here, by the way. This is a shoreline. And out here, well, there's something out here. And I'll tell you what that something is here in just a minute. If I can, I think we'll give him a blue eye. We'll do that. And of course, we can't figure or forget what that is, right? So let's see if you can put that together and figure out what this actually is. Anyway, I guess I need to get started here. This is a shoreline here, and what's going on is the farmer is going to build a rectangular pen, or at least part of one, and he's going to use the shoreline here as one of his sides, and we'll call this W and this length here. And we're given an area. He said that he needs to have 10,000 meters squared. So the area of this rectangle here is, or part of one anyway, is going to be 10,000 meters squared. He wants to minimize the perimeter. Okay, so we need to find the dimensions of W and L. So let's go ahead and write down our equations. We have, we're going to write down the primary equation first. So that's going to be P, and no, P doesn't stand for pig or pin, it stands for perimeter. And we're going to have two W's, right, a W here and one over here, and then a length, okay, a length. And let's write down a secondary equation. We said that the area is 10,000 meters squared, and this will be W times L here. W times L. Alright. Now, this is what actually happened here. He figured all this out and he fenced this thing in. He stuck his hogs in there, and well, he fed his hogs some peanuts one day, and guess what happened? One of the hogs did not like that and he decided to swim off. So we can kind of see part of the hog. Here's his tail and his snout, and well, anyway, he said, I'm out of here, and swam across to the other side where I think he could smell some a little better food than peanuts. He's allergic to peanuts. That pig was. He did not like that pen. Anyway, let's move on to the math problem here. I thought I'd throw that in there. What are we doing? We're solving for one of our variables here. So I always solve for L. It really doesn't matter what you solve for. Solve for whatever you want, I suppose. And of course, I flipped this stuff around and wrote L over here to the left. Now we're going to get our P all in terms of W. So we have 2W plus 10,000 over W. So now we got our primary equation all in terms of one variable. And of course, now what we're going to want to do, I think I left a zero off, didn't I? Whoa.